Right now, as you're watching this video, your brain is holding on to memories from today. What you had for breakfast, a conversation with a friend, maybe even a random thought you had while waiting in line. But here's the twist. Tonight, while you sleep, your brain is going to deliberately erase some of those memories. Not because something went wrong, not because you're getting older. Your brain does this on purpose, every single night, and it's one of the most important things it does to keep you alive and functioning, and the science behind why it does this is absolutely fascinating. For most of human history, we thought sleep was basically downtime. Your body rests, your mind goes quiet, and you wake up refreshed. Simple, right? Totally wrong. Modern neuroscience has revealed that sleep is one of the most active states your brain enters. Your brain actually consumes nearly as much energy during certain sleep stages as it does when you're wide awake solving a complex problem. And one of its primary jobs during those hours is deciding which memories to keep and which ones to throw away. Think of it like a librarian working the night shift, sorting through every book that came in during the day, shelving the important ones, and tossing the rest into the recycling bin. This process has a name. Scientists call it synaptic homeostasis, or the synaptic homeostasis hypothesis, developed by researchers Giulio Tononi and Chiara Chiarelli at the University of Wisconsin. Here's the basic idea. Every time you learn something new during the day, your brain strengthens connections between neurons. These connections are called synapses, and you have roughly 100 trillion of them. By the end of a busy day, your brain is buzzing with strengthened synapses, like a city with every light turned on at maximum brightness. That's not sustainable. If your brain kept adding connections without pruning, it would eventually run out of energy and storage capacity. Sleep is when the brain dials everything back down. During deep sleep, specifically slow-wave sleep, your brainwaves become long and synchronized. These slow oscillations wash across your cortex and systematically weaken most synaptic connections by roughly 20%. It's like turning down the brightness on all those city lights, so only the truly important ones still shine. The memories that were reinforced multiple times or tagged as emotionally significant survive this pruning. The random stuff, the face of someone you passed on the street, the color of a car in a parking lot, gets cleaned away. Your brain is being ruthlessly efficient, and that's exactly what you want it to do. But why would evolution design a brain that deletes information? Wouldn't it be better to remember everything? Actually, no, and we know this because of rare cases where people can't forget. There's a condition called hyperthymesia, or highly superior autobiographical memory. Fewer than 100 people worldwide have been confirmed to have it. People with this condition remember nearly every day of their lives in extraordinary detail. Sounds amazing, right? In reality, many of them describe it as exhausting and overwhelming. They can't prioritize. Every memory has equal weight. A conversation from 15 years ago feels as vivid as one from this morning. Their brains never properly clean house, and the mental burden can be crushing. This tells us something profound. Forgetting isn't a flaw in the system, it's a feature. Your brain needs to forget in order to think clearly, to generalize, to be creative. When you strip away the irrelevant details, what remains are patterns and principles. You don't need to remember every math problem you ever solved, you need to remember how to do math. Forgetting the specifics is what allows you to extract the general rule. Now, here's where it gets really interesting. Not all sleep stages do the same thing. Your brain cycles through different phases roughly 4 to 6 times per night, and each cycle handles memories differently. During deep slow-wave sleep, your brain replays memories from the day. Neurons that fired together during a learning experience fire again, sometimes at speeds up to 20 times faster than the original experience, almost like your brain is rehearsing on fast forward. This replay process transfers memories from the hippocampus, which is like short-term storage, to the neocortex, which is long-term storage. It's like moving files from your desktop to an external hard drive. Then comes REM sleep, the stage where you dream. During REM, your brain does something even more remarkable. It takes those newly stored memories and starts connecting them to older memories in unexpected ways. This is why you sometimes wake up with a creative solution to a problem you couldn't solve the night before. Your dreaming brain was literally trying out new combinations, linking ideas that your waking brain would never put together. Some researchers believe this is why dreams are so bizarre. Your brain is testing wild associations to see which ones might be useful. Famous examples include Paul McCartney hearing the melody for Yesterday in a dream, and chemist August Kekulé discovering the ring structure of benzene after dreaming of a snake eating its own tail. The emotional component matters enormously too. Your brain has a tagging system during the day. When something happens that triggers a strong emotional response, whether it's fear, joy, surprise, or anger, the amygdala essentially stamps that memory as important. During sleep, these emotionally tagged memories get priority treatment. They're more likely to be replayed, consolidated, and stored long-term. This is why you vividly remember your wedding day, but can't recall what you had for lunch on a random Tuesday 3 years ago. This also explains something darker. For people with post-traumatic stress disorder, the sleep memory system can become a problem. Traumatic memories are tagged with extremely strong emotional markers. During sleep, these memories get replayed with high priority, but the emotional charge doesn't fade the way it should. Instead of processing and filing away the trauma, the brain keeps re-experiencing it at full intensity. Some promising new therapies actually target this specific mechanism, trying to help the brain properly process and downgrade the emotional intensity of traumatic memories during sleep. So what happens when you don't sleep enough? The consequences are dramatic. Without adequate deep sleep, your brain can't properly prune synapses. Connections that should be weakened stay strong. Your brain becomes noisy, like trying to listen to one conversation in a room where everyone is shouting. Studies show that even one night of poor sleep reduces your ability to form new memories by up to 40%. Your hippocampus, that short-term memory inbox, essentially fills up and stops accepting new information efficiently. Chronic sleep deprivation is even worse. Research has linked it to accelerated buildup of proteins associated with Alzheimer's disease. During deep sleep, your brain activates what's called the glymphatic system, essentially a waste removal process that flushes out toxic byproducts, including beta-amyloid plaques. This system works by shrinking brain cells by about 60% during sleep, creating channels for cerebrospinal fluid to wash through and carry away the waste. Skip sleep regularly, and you're letting metabolic garbage accumulate in your brain. It's like never taking out the trash. Eventually, the mess causes real damage. Now, here's the practical takeaway. You can actually work with this system instead of against it. If you're studying for an exam, reviewing material right before sleep is one of the most effective strategies. Your brain will replay that information during deep sleep and move it into long-term storage. Spacing your study sessions across multiple days is even better, because each night of sleep provides another round of consolidation. This is why cramming the night before an exam while skipping sleep to do it is the worst possible strategy. You're loading up information while simultaneously disabling the system that would store it. Exercise also matters, because physical activity has been shown to increase the amount of deep, slow-wave sleep you get. So has keeping a consistent sleep schedule. Your brain's memory processing works best when it can predict when sleep is coming and prepare accordingly. Here's one final thought that might change how you see your sleeping brain. Every night, you are not the same person who went to bed. Your brain has edited your memories, strengthened some connections, dissolved others, and reorganized your understanding of the world. The you who wakes up in the morning is literally a revised edition. Your brain has been running its own editing software all night, cutting what doesn't serve you and reinforcing what does. So, tonight, when you close your eyes and drift off, don't think of it as shutting down. Think of it as your brain's most important work shift beginning. The night crew is coming in, and they've got a big job to do. Let them do it. Your future self will thank you.